Hello, world, and welcome to the brand new format on the Flashover channel called The Code Polyglots. I'm Stefan, and I had this idea for this format a couple of months ago, almost a year already, isn't it? Where I originally started programming in C++ and Java, and then later I moved to C Sharp, and I was able to use the concepts that I learned already without really knowing their names to learn a new language. And this is now why I would like to start this new stream, where we in each episode take a look at a programming concept that is maybe not exactly looks the same in every language, but one way or another, if not in one way or another, will manifest in most, if not in every language, programming language out there. So I'll be representing the C Sharp part, and I recently learned that there is a bit of a concept of value categories, and well, I kind of always well, not really use them, but they kind of impair or um, surround every line of code I write. They're always there, but I never really understood the concept. And today on the show, we have Mate, who will be presenting the C++ part where the concept of value categories is the strongest evolved. Hello, Mate.
Hello, Stefan. Thank you for having me.
Thank you so much for joining. Would you like to give a brief introduction to the audience?
Yeah, sure. So I'm Matej. I'm a C++ developer. Well, lately I don't develop as much anymore. I'm like more like drawing stories left and right on the board. C++ developer in a company that does trading software, which is where we met, right? And yeah, in general, I like C++ and also like what it says on my little bio here on 10 Forward Social. I'm a Trekkie, obviously, because I joined 10 Forward Social. Um, Nerd, software engineer, coin collector, which I like a lot. And it says here that I like C++ and Python. So yeah, that probably describes me best. There's no other dimension to me. That's all I am.
I'll post a link to your profile in the chat if people would like to follow you. And well, the official name of this is the code Polyglots, because all of us have our main languages and we represent the concepts behind them in this format. But when we met, we also did in the company we also did some internal knowledge shares, and at some point. Some team member then said we should do the Mate and Stefan show. So that's the unofficial name.
Yeah, I guess that stems from the fact that when I presented, you had the most questions and vice versa. So it looked like we're having a conversation anyway. And like most other people are just like with camera switched off, which I understand. Like it's way more comfortable this way. But when you're presenting, it's slightly I just made a joke. Is anyone laughing or is
Yeah.
everybody eating a sandwich? Whereas you were on the other side, you know, asking me questions. So probably that's how the idea for Mate and Stefan show was born.
And for one topic, when you presented the value categories and its implications already to me, and I had many questions, and I realized, hey, wait a minute, this is also maybe not to that full degree, but the concept still exists in C Sharp, and the we cannot escape the rules behind these concepts. So
Mm.
let's take a closer look at what are value categories. Taking a look at the C++ reference, I gave this
Good luck.
a very brief read. It's rather cryptic.
Yeah, good luck with this. Uh, yeah, so this is one of the things about value categories. Like on one hand, everybody thinks they understand them because it's like R value and L value, and R means on the right hand side of the equation, and L means on the left hand side of the equation. On the other hand, nobody really understands it, right? And with nobody, I include me. So if you ask me any hard questions, I'll just unfortunately have to say I don't understand, which will happen during this talk, I'm sure. So on what, because of this, there are two kinds of resources you can get online. One kind of resource is the CPP reference page on value categories, which after you read it once, you realize you have no clue what you've just read. After you read it 10 times, you're still thinking, I know every word, I still don't understand it, right? And there's like 90% of other resources out there that are just plain wrong. Like not entirely wrong, but like wrong in details, so they wouldn't give you
Mhm.
full understanding. So this is why I found it like intriguing, because I didn't get it.
Mhm. Well, then let's dive in to the value categories. Would you like to start?
Yeah, sure. And also thank you for having me. In terms of thank you for allowing me to try to explain this again, because the last time in this show and tell, I am aware I bombed. Right, I know I explained everything correctly as far as I know, but you can see how nobody had questions in the end. Right, when you when you finish your presentation and it's all clear to everyone, you know you failed. Right, you did not deliver. Right, so I'm kind of excited. I got another opportunity to transfer my excitement about value categories to other people. So thank you.
So
And
ready,
I
ready for,
personally,
I see
yeah,
you're ready for round two.
yeah, I'm totally ready for round two now. So yeah, I like this topic personally because I kind of think it permeates the entire programming world. Like you said
Mhm.
before, like it might not be exactly specified in every language. Um, it is definitely specified in detail in C++ standards. If you want details, just open that cppreference.com and scroll to the end. Um, but while it's not defined in every language, you can still feel it runs
Let me see.
underneath those, right? It's almost like a mathematical underpinning of programming, at least for the procedural programming. I still don't know other programming concepts well enough to comment. So I think for that reason, I think it's a good start for your polyglot series, because I think it like applies to all languages.
Mhm.
Yeah, so I started being aware that this applies to other languages when I tried to figure out this weird error that I got in C Sharp once. I was coding something. Actually, it wasn't even me coding, it was my friend was writing a game and had like, oh, look at this stupid error message from C Sharp, which is clearly wrong. And I thought, oh, I've just read about value categories. I don't think the error message is wrong. It's just
Mm.
not telling you what happens underneath, right?
Mhm.
So it was what he's done is he had a structure and a function that will create objects of that type and return them from the function. It's just that, yeah.
Let's I'll just draw the example. So having let's actually switch here. So let's build a structure, and we also have a user class as a holder for my methods,
Hmm.
and we have a static method that will return. I call it create.
Yeah, that's good enough.
Return new my struct. Mhm.
Yeah.
So let's invoke that. Create. Oh, we need to make that internal so that it's visible.
And now try to give some member to the structure.
Let's make, okay. I'll now do something that you shouldn't really do. I just make a public field on the
Okay.
struct, but let's for the example,
Should the
let's
structure
use
normally in
that.
C# have private fields?
Yeah, fields usually are private, and then you have via properties. You then have accesses via
Uh,
properties. So you would do a private
oh,
field
okay,
and
I
then
see.
have a
Oh, that's just good style. That's not language grammar, right?
to no, yeah, it's good style because
Yeah, throw it out.
usually structs are immutable.
Uh-huh.
Not all of the structs.
Okay.
Also, what am I doing wrong here? I am. Oh yeah, be gone. So this is now a getter, so now I can access the
Yeah.
field. But actually, yeah, I guess we could also do just a property that has get set semantics. But let's keep it simple. Let's go back to the public
Yeah.
field.
Public int field. Now, what that
And
creates return, try to assign to it. Bam.
right.
See, and what does it say?
So we cannot modify struct members when accessed structs is not classified as a variable.
Yes. So now try to assign that field to something rather than assigning something to it.
Oh yeah. So this will be an integer. I call this now. Becomes a local in this method that we are.
Yeah, okay.
Oops. And that
Yeah,
seems to work.
and the error goes away. And then you're thinking, what field is like a member. Let's field is this integer. I can read from it, but I can't assign to it. And also the error message doesn't really help because it just says something about isn't a variable or something. Right? You can think, how is it not a variable if I just read it?
I see. Yeah. So is the answer value categories?
Yes. So in this case, it is like the field was meant to be on the right-hand side of the equation of the assignment operator here, right? It was meant to be on the right-hand side, therefore an R value, right? If it's on the left-hand side, it doesn't work because it's not an L value. And you can see this by, in my mind, I'm trying to think, is it like I said here, is it like a number one in code? I don't mean an integer, I just mean number one, the thing that you assigned to the field, right? If it's like that, then it's an R value because you can't say one equals something, right?
Right. I can't say I want my one now to be 6.
Yeah, you can't because one isn't a variable or
Yeah.
assignable. It's actually the same error message, which surprises me. Oh no,
The
it's not
assignment,
entirely the
it's
same.
similar though. The assignment target must be an assignable variable property or indexer.
Yeah, see. So even though C# doesn't say L value and R value, like once you, at the end of this chat, you will understand what's going on the difference. Right? Yeah, so this is what prompted me, like we only talk about PR values and GL values and X values and like stuff in C++ world, but actually it makes sense everywhere. It's not something that C++ invented. It's something I think that C++ discovered. It's not C++ because
I see.
it goes way back. It goes way before the C language, and it was actually defined as right-hand side of the assignment and left-hand side, and it was just about that, right? And it was, if I say int a equals 5, you know what? Why don't I just do it in code while I talk? I think it will be
Sure.
better if I
Let's
just
jump to your screen.
better than me flailing around. So if I say int a equals 5, right? So in old world, like 5 is R value and a is L value because the point of what's on the right hand side of the assignment operator is that it produces a value of some sort, right? It's a formula how to derive a value. On the left hand side of the assignment operator is a formula how to derive an address in memory to store this value in. So this was a pattern how to discuss these sorts of things, like before C++11. So C after that adopted this because C is like a parent to C++. C adopted this methodology of like this categorization, but it generalized it so that it doesn't speak about assigning anymore, because you know how in C++ you can say plus plus a, it'll increment a, but there's no assignment anywhere. Like the assignment is like implementation detail, but it still stands. Like this is still either L value or R value, right? This is what like C brought to the table.
So
And
C
then
C had only R, L and R, or was only speaking of L and R values. Do I get that right?
yeah, completely right. It was even more like people in C were looking at this and they thought everything makes sense on the right hand side of the assignment operator, but only some stuff makes sense on the left hand side of the operator. So there were some ideas that even R value is superfluous, that we don't need an R value expression, that it could just be L value and not L value, right? So like diminish two into one, right? How to simplify. However, they got really wrong because C++ people came around and had a look, and they said this is too simple. We're C++. We're C++. We need let's put some sauce onto this. Right? So they kind of looked at it for a while and tried to generalize it in this way. Like it's about identity of the like the expression, and in this case, let me just delete so that it doesn't disturb too much. In this case, this has identity, meaning it has an address in memory that can store values, right? And this doesn't have identity because it's not in the memory. And the way to make this distinction less abstract would be this example. Like I can take an address of a variable in C, right? So I can say int reference B is A, right? So this doesn't copy the value in the B. This just creates a new alias, right? B is now an alias for A, so meaning B is just another name for A, which means these two have the same identity. They're the same thing. It's just two different variables for this. And I can test that, right? I can say, for example, instead of this hello that serves no purpose, I can say, okay, is the address of B equal to the address of A? Right? It's not a compilation error. And if I try to play it, yeah, you get 1, meaning true, right? I couldn't possibly do this with stuff that doesn't have identity, for example, with 5, right? Because what would happen, like I would try to get the address of 5, it's immediately a compilation error, but it tells you in detail, like it's a non-const L value reference cannot have R value types, right? Because 5 is an R value, and you can't assign it, you can't bind it to a non-const L value.
So everything that I don't store in a variable or a local doesn't have an identity, and therefore I cannot grab the address of it. Do I get that right?
Yes, you can't get the address of 5 because that's kind of meaningless, right? It doesn't exist. So not only you can't get it, you can't compare it. You can't say is this 5 living in the same memory address as this 5. It's a meaningless statement, right? And also, like, while I could say, let me just change this back just because I hate watching compilation errors. If I went back to int reference B and assign it A, I could assign something else to B, right? And now A and B would both have a value of 6 after this line in code. Like I cannot assign a different thing to 5, right? Because 5 doesn't have, you can't grab it, you can't hold it. There's nothing you can do to it. It just, doesn't have identity, right? So in implementation terms, I think this just means doesn't have a memory address that you could read. In a more like abstract concept, it means it doesn't have identity. And from now on, I'll try to talk about this as identity because that's how I learned this thing. But you could probably hear other explanations too. Yeah. So from here on, you can see that one property of values is identity. Either a value has one or it doesn't. It's fairly simple. The other property is whether the value can be moved into an address or does it need to be copied.
Before we jump to that, I would like to. I now have this explained something that this made me realize something. What happens in C#? Well, it doesn't have the names. It doesn't really speak of identity, but there is something like an alias, so that you can also have an alias. So whatever happens to the new alias happens to the original as well.
Yeah.
Well, I guess it actually then becomes, now jumping to my screen, so we're on the C# world now. I guess when they have an alias, is it actually then, what's the meaning? Which is the original? I guess this is more, This is more of a philosophical question. But well, per default, we pass in, well, in C# we have both value types and reference types, and we usually pass them by value. So I'm having here a method where I'm passing an integer, that's a value type, by value. And here I'm having a method that takes a string, which is a reference type, but also by value. So we are copying the actual value of the string, because per default we copied the value. And here we copy the reference. And now if we initialize a number and a text, we call these two methods that copy them by value, both the value and the reference, and we assign something new and then print them to the screen. We still get the original values of 1 and the original string because we have new copies. We have new copy of a value and a new copy of a string. They are not aliases. That's actually a new identity. But we can also pass them by ref. Having the same methods again, they are now modified with the ref keyword.
You said identity. See how it permeates language?
Yes, I would now always say, well, I never used identity before. we prepared 2 days ago and never, it doesn't go away.
You'll just see it everywhere now, like I do.
And aliases, identities and aliases. And I guess there's now, what happens here, so we can pass a ref to that value type, and now number is an alias to whatever we called it with, same with a reference type. And if we reassign them now, since they are aliases, they aliases to the original ones. Now actually those get changed to the, I of course need to call them by ref, and in C#, then if you pass by ref, you need to specifically specify ref. So we now pass the address and their aliases now, and then we actually can change what we originally declared. And now when you think about identity, I think in C# this is called sometimes location. We can also, rather than a ref, which is mutable, we can also do an in, which is also passing it by reference. So this is still an alias, but it has a read-only semantic, so we can't assign to it. I need to comment that out. That doesn't compile. But we can actually pass an R value, like just a number, and just passing the number 12. That's an R value, and we don't get any warning. If I don't want that, if I actually want to enforce a location, well, I would need to use the ref. The ref requires a location. If it's by ref, I can't pass in an R value because it requires a location. If I want to have both, it requires a location and read-only semantics. There is this new thing that I learned in C# 12, so that's pretty new. Going through the docs, C# 12 added ref read-only parameters. And when we go into the docs, they also talk about R values and L values. So it is not really in the official documentation. You won't really find R values, L values. But in the language design team is using these terms as well. I was like, hold on, I heard of these. And if we now use the ref read-only, so we require a location, but still have read-only semantics, we actually get a warning that, we need to pass a variable. I guess translated, this would be an L value, something that has identity to that method. If we compile that, we see what the compiler emits is, if we jump to that method, an attribute that says requires location, which is now telling the compiler, okay, if you pass in an R value, emit a warning. Since this is a very new feature for backwards compatibility, it's just a warning, but you can turn, for example, this warning on as an error, and then you can't compile either. But if it wasn't for backwards compatibility, then I guess this would be an error. And so there is ref
location
in
is just
and ref
word
only.
for identity, right?
Yeah. Requires location, requires identity. That makes sense. Cool. Um, Now you mentioned move. So what can I move? Let's jump back to C++.
Before move, because it's a complicated topic that I regularly screw up, and I'd like to delay that as much as possible and avoid the conversation. I'd like I've seen right now you've done, if you did ref, then you had to use a variable, but if you did in,
Jump back.
makes it read only, and then it can either be a variable or also could be a number, right?
It could also be, yes, I can
Yeah,
also, so now I made this in, so I can pass in an R value, but I can also pass in an L
right.
value.
So this is also really similar to a concept that C++ has, another like polyglot thing. If you switch back to my screen, I'll show you. You know how I earlier said, like I'll delete this. You know how I earlier said that you can't take address of like 6 because it
Mhm.
makes no sense, right? But what you can do is you can const int reference, right? It's called, I think it's called temporary materialization, which like the compiler will then like see this and say, okay, since it's const in reference, I can just work with that, right? I know you won't be able to change it because you can't change 5, but like temporary for a while, you can use this b as a placeholder for 5, which I think is, right now I'm not sure whether there's really any deeper underlying concept that like results in the same thing in both languages. But if you have const int reference, you can assign 5 to it. If you just have int
Mhm.
reference, you can't. Whereas in your world, if you have in, it can be 5 or a number. But
Yeah.
if it's just reference, it can't be a number because references can be changed, right? So that's
Ah,
another thing that's
right.
the same.
So if I would be able to get a reference to 5, mutable reference, then I could
Yeah.
technically assign something new and then 5 becomes 2 or something.
Well, this is something where they put in like a concept they put into C++ that I think is very useful, and we should use it more in generally in our lives. If that happened, it's undefined behavior, right? And they wash their hands of all the possible complications that happen afterwards, right? So if it was somehow possible to, well, it is. I just don't want to try it because you can cast, right? You can cast the constness away and say,
Ooh.
you know what, compiler, I know what I'm doing, you know,
Yeah.
just let me shoot myself in the foot. Like it'll allow you to. But after const cast, it's probably undefined reference in like in general case, because it was supposed to not be changed, right? Especially in this case, I don't know what happens. I assume that if I ever tried to change this, it would be uh, undefined behavior afterwards. I don't know what address in memory you would even change with this. Right?
It
Okay,
doesn't really make
actually,
sense, no. Since it
I
doesn't
can try
exist in
to
memory, we'll
display
just
it and
change.
see.
Yeah.
It's temporary. It temporarily exists in memory, so it's called temporary materialization. It does have an address for a while, right?
Hmm.
So it's kind of,
Ooh. Does
it's
it
kind
does
of
it maybe
hmm?
does it maybe does the compiler implicitly create something that has an address that is pointing that has the value 5?
My bet would be it actually creates a value on the in the memory, but
Mhm.
compiler is free to do like how compiler implements the specific outcome is up to
Mhm.
compiler. So this is like optimization detail, not implementation detail. So
Could
the C++ standard will just prescribe what needs to happen.
mhm.
How that happens, it's up to compiler a lot of the time. And like earlier, you had like something didn't even happen because the variable wasn't used. Like if I switched on compiler optimizations. Actually, let's play around with this because I really want to avoid the topic of moving. Let me go to the compiler explorer instead, and I will say I'll delete this because it'll just mess up the compiler output. So if I have int a equals 5 and I try to output 5, the program returned 5, and look at the compilation, what's compiled out. So this would be, see, this is like in the assembly, this part of my screen is the assembly output. right? I'm not very good at reading assembly, but I just take
Oi, oi,
some
oi.
clues. Can you see it?
Yes, yes, yes. But my assembly reading skills are also
Oh yeah, so
pretty much
yeah,
unavailable.
we're in the same boat. We're in the same boat.
Ooh, there is
So
hovering. Helps. Cool. Oh, this
yeah,
helps a lot.
so this is this is how the main function starts. Like it pushes stuff onto the stack, yada yada. Don't understand. Let's avoid this topic. So this is the line that's actually interesting. So it takes 5 and moves it into this address on the stack, right? So you can see 5 is just here. 5 isn't. It's just like in the binary file itself in the
Hmm.
assembly. It doesn't exist somewhere. It's stored in memory, right? And one of the things I just wanted to show here is like how compiler can do anything they want. So my application here just assigns 5 to A and then returns A. What I can do is switch on the optimizations, and the resulting program will just move 5 into
Hmm.
the result, right? So it
Hmm.
just skips everything. So what I wanted to do now, just to see what happens if I tried to temporarily materialize 5, what happens? Right, so it's a lot more, right? So 5 is first moved to this address in the memory, and then this address is LIA, I don't know what that means, computes the effective address, right? So it's a bit more complicated now just because of this. So because 5 was moved into this address and then something else is computed before it's returned in the end, I assume like 5 actually gets stored somewhere in the
Hmm.
memory, either registry or somewhere in memory. And then when I say A, it'll actually pick it up from that memory again. Like what if I say +1? I would be able to see 1 somewhere, right? So it adds 1 to EAX. And EAX was moved into from this address. And on this address was, I don't know what, but you can see there's plenty more memory manipulation now, right? Whereas if I just did this, there was less.
Hmm.
So I'm guessing that when I take constant reference, it'll actually store it in the memory.
Hmm. Can I, if I do this temporary manifestation within a method, and then I
Yeah.
return a reference to that temporary temporary manifestation, is this possible, or is this a compiler error because I could leak
No,
something that's
that's
on the stack?
no. So that's possible, and that's a feature of C++. You can return temporary stuff as long as they're stored in a const reference. The compiler will keep that thing alive until it goes out of
Ah,
scope and destroys.
I
So
see.
this is well, not common way to implement factories of objects, but it's one of the ways, right? And it's a known rule in C++ that you can do it. It looks like you have dangling reference now, but
Yeah.
it doesn't. The destructor won't get invoked at the end of the function because it's returned into, because it's bound into a const reference after the function returns. So yeah,
Mm.
that
So
would
so so
work.
so const is like extra safe. I can't do anything wrong with const.
Well, this is one dimension to const. You can't do anything to it. The other dimension is this, like object lifetime maintenance that comes with it.
Hmm.
Of course, this is just for temporary materialization. Like if I have int a and I screw up my program and say 6 a, and I say a, and I did that in a function and I returned it, this would now be a dangling
Yeah.
reference. Yeah,
Yeah.
so it doesn't like save you from everything.
Hmm.
Like the rules for lifetime management in C++ still apply. It's just in this case where it's temporary materialization, or I forgot, temporary something, right? In this case, it'll allow you a bit more. So also in this case, what I can showcase, so as the a+1, and the result is of course 6. But if I go here and try the compiler optimization again, bam, just moves 6 into the output, right? So
Mm,
it
yeah.
skips the whole operation of adding up, just like does it. So cool, so cool. Let me have 2 seconds to geek out. Wow.
No,
Okay.
that's what we're here for. I love how the compiler, uh, modern compilers optimize. Well, we can still like write our code how we intend, maybe not from a code point of view, maybe not the most performant, but the compiler just knows stuff and optimizes
Yeah.
all the stuff away. So we can, what's the English saying? We can have our cake and eat it too.
Yeah, exactly. And this is why I always keep saying, like, people wish to, especially in C++ world. I know, like, C# world is a bit better in this because people are more oriented towards what can I deliver, whereas in C++ we're all about performance and optimized code, and we know better than everyone else. And then we like to operate with pointers and addresses, and we optimize this and that. And then I keep thinking, well, try Compiler Explorer, write your most crazy code, turn on compiler optimizations,
Mm.
and then it'll just return 6. Like, you can have hundreds of lines of code. In the end, it'll return 6. And it's like a school of thought in modern C++. Just write meaningful code. Like, write the code, write what you mean, not what you
Mhm.
want the C++ to do for you. Write what you mean, right? So if something is meant to be passed as a reference for whatever reason, do it. But try just creating a copy first. For example, copy is also thread safe, right? If you don't need it to be pointing to the same object because you won't be
Right.
manipulating it, it's automatically thread safe, for example. And compiler might choose to pass it by reference anyway because it sees it's cheaper, right? So stuff like
That's really
this,
cool.
just like it's like write the code in terms of what you want to see, like encode business logic rather
Mm.
than encode what the computer operations will be.
Right,
Anyway,
right. Because the source code is for humans, or high level
yeah,
language source code is for
yeah, for
humans.
both.
The
Like, it's for
machine will
compilers,
deal with it. Yeah.
but for compilers as well. Like, it's not even just for humans, for compilers too. There's like I won't be able to remember now, but in conferences, a lot of the examples they give is by saying, if you just tell compiler what you want as an outcome, right? The compiler will know how to do the optimizations. But as soon as you start dealing with addresses and then assigning and like
Ah.
pointer manipulations, compiler doesn't know what you meant. So
Mhm.
compiler has to obey your instructions. If you say, this is an integer pointer, give me the second byte out of this, it will give you the second byte out of this. But if this was like a vector of integers and you told him, give me the second integer, compiler has no free hand. It knows what you wanted to achieve. It can try and find another way for that, right?
I
So
see.
many times the code that's been manually optimized doesn't even run faster.
Because the compiler knows the
Yeah,
idioms and
yeah.
optimizes them, perhaps
There's
even better than
like
I could. Yeah.
yeah, there's hundreds of people with PhDs out there that are all trying to optimize G++, right? And I'm here alone, trying to write my game, not even knowing the rules for R values. Right? So this is, yeah, it's always fun to have code reviews with me. I'll always tell you to write your code more simple. Right?
Mm.
Tell you to not be so clever.
Well, I guess our future selves will thank you when we then have to maintain our code again, like the next day already, isn't it?
Yeah, it's always in the next month. What did I do? Why didn't somebody stop me? Well, I think I can't avoid the subject of moving any longer. Right?
There is no
Do you
stopping.
have
No.
any? Do you have any questions? Does anyone have any questions?
Yes, if
No.
there are questions on stream, then put them in the chat, and
Okay.
we'll get to them. I guess
Okay.
it's
So moving.
it's time to move.
It's time to. Yeah, time moves on. Yeah. So if you forgot during my long diatribe about how cool the compilers are, if you forgot, the first property was identity, and it's fairly simple. Does it have an address? Or like your attribute in the code that I've seen requires
Location.
location. Does
Yeah.
it have location? People call it different things, but it's identity, right? The other value, the other property of values is, can they be moved into an address or not? Right? So yeah, and this is the part I always struggle to explain clearly. I think this is where I lost everybody on that last show and tell that we had.
I
Like,
see.
also it was Friday afternoon. Everybody's kind of winding down.
It's- There's many variables to the equation. Yes.
Yeah, yeah. And also, yeah, I don't blame them. It's one of the reasons why I struggle to clearly explain it, because I don't clearly understand it myself, I think. So some humbleness is in order. But if I have any chance of explaining the rest of the value categories, I think we need to cover this ground and what I mean with move. So let's start with simple. We already have int a equals 5, right? And I already shown before I did my compiler optimizations here how 5 doesn't have any address. It's not copied from anywhere. It's clearly moved. And like, funny enough, in x86 assemblies, that's actually called move. Oh, but now I see that it says copies the second operand. So never mind, I'll just hide the pop-up command. So it just moves the 5 into an A. Well, in this case, A would be this address in memory, right? It's just moved. It's there was no 5 in some other address. It's the only 5. It's just a number. It's mathematics, and yeah. So this is a property of the values. I could copy it. I could say int b equals a. Now, this is copied, right? But this is moved.
We move
And this
5
is the
into
difference.
A and then copy 5, or the
Yeah.
value of A, which is 5 into B. Yeah. So we now have
Because
two
now,
5s.
yeah, A is still 5, but B is another 5. Like if I change B, the A won't change because now it's been copied. It's another 5, right? So this is a difference between copy and move. And if you struggle to understand this bit, it's because this difference didn't exist until C++11. It was irrelevant because it's just integers. Does it really matter? Right? What does it mean to move an integer? Right? And yeah, this is why it's a bit harder to understand. We're not born with this difference. Like 5 was never moved into 8 before C++11. It was just something that was assigned. The details didn't so much matter, or if they ever mattered, they were really abstract, and it was pointless discussing them in like software that we develop. And like I said, for integers, it still kind of doesn't kind of matter to this day. The problem is classes and maybe bigger objects, because for some, copy can be expensive, right? I will later create a class that has like creates like reserves a chunk of memory, and then it's expensive to copy that thing because it's a lot of memory, and you don't want to do that sometimes. But for some occasions, copying is an error, right? So it's not even just performance optimization. It can be an error outright. For example, imagine there's a class for mutex, which mutex is a type in C++. You can have a mutex variable. But now, if you lock a mutex, this is something that exists on operating system level. Like it's outside just your code. So if you copy mutex to another variable, you've copied the code level of it, but the operating system still has the same underlying resource. So mutex should never really be copied. That's an error. That's not even just performance optimization. It's really an error, right? So they came up with like how to manage this in a general way. And now I remember, like there was after C++11 was released, and Strostrup, this like the big boss of C++, the inventor, the crazy inventor of the new technology. So he kind of joked that like everybody knows how to move. You give a child an apple in like one hand, or maybe it wasn't apple, I don't know. You give a child apple in one hand, and the child would be perfectly capable of just like moving the apple into the other hand. Or I need to show it like this way. Like it takes a computer scientist to create a copy of apple in the other hand and then destroy this first apple, thus moving it. So I thought this is a really good analogy how basic we are sometimes, right? So yeah, let me go to this example so that it's a bit less hand wavy. So let's say I need, okay, I'll fold this for the moment because it's not so important. And I'll start with copy pasting something because this is getting long enough. Right, so if I have a class that tries to hold some resource, for example, I have an integer pointer, int pointer, and when the class is constructed in constructor, I will create 1000 integer worth of space. Like this could be a million or 10 million. Imagine a gigabyte of memory. Let's say this is a large resource. I want to make this class expensive to copy, right? So because I created it, I then need to delete it. So these are two operations that go hand in hand. For each new, there needs to be a delete, right?
This was when I started with C++. Was if it wasn't the first lesson, it was the second lesson. Yes, every new needs one delete. Exactly one.
That's exactly right. That's exactly right. But I just found an excuse how to delay the move explanation a bit further. So this isn't encourage C++ anymore. Like I hear so often how in C++ you need to manually manage memory. You don't, right? I'm using this as an example. If I saw this in one of my code reviews, I would say, please fix, right? But like programmers, like even C++ programmers, haven't yet come up with the times. They still claim this. In fact, one of my pet peeves is all the websites that claim that in C++ you need to manage your own memory. Like I'll just do it. I'll just do it now, and you'll see. So if I Google difference between C++ and C#, I bet the first 5 pages will tell me you need to brief history, when was it created, major differences. C# offers automatic, but C++ doesn't. Requires you to manually manage what C# does automatically. Right? It's alluding to pointers. Again, you don't need to manually manage. We can talk about how I would implement this later on. But this is every website you open, it's the same, and it's all wrong. It's all misleading. Geeks for geeks. Memory management. In C++, memory management is performed manually by the programmer. Not true. Not true at all. Like you can if you want to, but you certainly don't.
Right.
Right? You can see like website after website. It's all the same. Like okay, the fourth one. What does that say? What does it say about memory management? Okay, C# has automatic memory management, which is true. In C++, yeah, acceptable. In C++, you need to deallocate and allocate memory manually. See? All websites. All BS. Anyway, back to move. Right? This is just to say, like,
while we get there, Alex Root 13 is here. Thank you very much for joining.
Hello, Alex.
Yes.
Yeah, I just had to use this long excuse why I ever wrote this code. And in fact, I haven't written this code in such a long time that before that I had to Google how to correctly delete because I haven't deleted in a really long time.
So that
okay,
but because since in .NET we have automatic memory management, you can also write. Well, it's not a destructor that you write. I think it's called a finalizer. You shouldn't. It's like the expert mode. You usually don't do that, but it's then up to the garbage collector when to call that. Now in C++, this is deterministic when the destructor is called, when the variable goes out of scope. Do you remember that right?
Yeah, so it depends on circumstances, but in all circumstances, it's perfectly deterministic when the destructor will be called. It's one of the features. You know when it will happen. And one of them is, yeah, you're correct. At the end of the scope, all the variables will self-destruct by compiler inlining a call to the destructor for them. No matter how the function exits. If it exits via, because you know how we can have multiple returns in the function, you can have them in C# too, right?
Yeah.
Before each return, it'll destroy, even if you have 3 different returns. You don't need to pay attention to when it gets destroyed. If it throws an exception, it'll be destroyed. You're pretty much guaranteed by the rules of the language that every time that for each one constructor, one destructor will be called at predictable time. Right?
So I don't, even if the exception case, I don't need to have a try finally block and
No,
invoking it
finally doesn't
manually.
exist in C++.
Language take. Okay, yeah, because
Doesn't even
oh
exist.
yes, because I don't
You
need
have
it
try
because
catch, and
it's happening. Yeah, I see.
you're supposed to finalize in your destructors. And also the order is predictable. So if you create object 1 and then object 2, you might have used object 1 to instantiate object 2, right? So it then destructs in the reverse order. So if you've created 3 objects 1 to 3 and an exception is thrown, it'll be destroyed 3 to 1, and then you're in the catch clause.
Right, because I could pass object 1 to object 2, and then I need to first clean up to 2. Yeah, I guess this is could make, not sure if I get it right, but yeah.
Yeah. So I don't know if that's the only reason. I predict that this is one of the reasons, because otherwise, like, you could have the destructor could rely on something that hasn't been destroyed yet but will be, because it was created with that passed into.
Yeah.
So if you destroy that first, maybe the second destructor will have trouble. And you can't get out of this trouble anymore, because destructor doesn't return a boolean whether it was successful or false, right? And also, while constructors can throw an exception if they go wrong, the destructors can't, exactly for this reason, because it's called stack unwinding. While the destructors are called because the exception is thrown, you can't throw a new exception, because what sort of destructors will that start calling? So in that case, your program is just dead, just wiped. There's nothing, just ends. You can switch off your PC. Go home. Just give up.
Destructors never throw, or should never throw. It's an error.
Should never throw.
Should never throw.
You can throw. Like, the language doesn't prevent you to throw from destructors. It's just kind of agreement between programmers that they won't, because that would cause a lot of problematic code. Right? Of course, you can throw, and if this isn't a library that you deploy to multiple people and only you will use, and every time you use that class, you will know this destructor can fail. I can't use it in a try catch statement, or I can make sure that it will never throw. In that case, you can, but you have experience as a programmer, right? How many times does it happen when you decide, I'll be really careful and the mistake won't happen? How many times did you actually succeed?
Minutes afterwards, I failed already.
Yeah, it's about the minutes range, isn't it?
But can I explicitly call the destructor? No, that's implicitly.
Yeah. No,
can I? Okay. So I could call it then twice if I is that also if I delete, then the destructor is called?
Let me delete the move demo, because I welcome this chance to talk about destructors instead. So if I create it, I need to leave B, because otherwise it'll be a compilation error. So if I created a resource, right, I can say resource dot, and I think it's, yep, I've just called a destructor. It's it's a function.
Will it now be called again at the end of the method? So will it now be called twice?
That I don't know. Let me try this. So if I run this, will it fail? Where am I? It didn't fail. I'm not sure if this is the rule or just compiler, the way this compiler works. Cout just called destructor. Let's see if it called it twice. Yeah, it called it
Ah, I
twice,
see. Hmm. Hmm.
which in general case, it could be an error. Right?
Yeah.
You might be
Got-
trying to unlock a mutex that was already unlocked. I don't know if that was a bad example, but you know what I mean. Okay, you could dereference, you could decrement a reference count,
Yes. Mm. Hmm.
and then you created a memory leak that way. Right?
Hmm.
It's not memory leak because it would clear anyway. Yes, let's stay with this. You could have a reference count and destructor would decrement it by 1 because now this class doesn't hold to that reference anymore. And if the
Hmm.
destructor is called twice, it would be the wrong count, amongst other problems. I'm pretty sure you can get into really weird problems really quickly this way because C++, although you don't need to do memory manipulation, you can, and in this way you can like shoot yourself in the foot. Okay, so let's just delete this wrong code before somebody takes a screenshot and says this is what Matei does as his day job.
So if we now, I guess to get back to move, when I
Yeah,
how's the
yeah. Let's get back to
constructor
move.
now called when we move? Now I'm curious.
Oh, we're not there yet. I first have
We.
to show you how how it's problematic. Right? So this is problematic because I could have resource 1 and also I could have resource R2, which I will copy from R1, right? So what I've done now is shallow copy. Like C++ would provide the assignment operators for you if it's trivial for it to do. And int pointer is just a value. It'll just copy int pointer, right? And I can even demonstrate this. So r1.p, I want to display this, and then in new line r2.p. So if I run this, see, it's the same pointer. So both resources, R1 and R2, yeah, now point
Point to
to
the
the same
same
point.
array. I don't have two 1,000
Yeah,
lengths array. I have one. Yeah. Hmm.
yeah, shallow copy. And then
Hmm.
what will happen in the resource destructor?
Ooh.
It'll try to delete the same memory. It'll try to free the same memory twice because it doesn't know that the other class is also sharing the resource with this, right?
Hmm.
And then this is where all the ownership shenanigans come from. Like who owns
I
the
see.
pointer now? Who's the original class? Like I said
Yeah.
earlier, it matters which is the original object.
uh, Eric on stream was referring, I guess, to earlier from the calling the destructor explicitly. This is amazing. This open store I've never thought of. Okay, so we now have two
Yeah, so we now
two
have to think.
owners. We now have two owners of the same resource. So who is now
Yeah,
responsible for
both
cleaning
think
it up?
they're owners. Yeah, both
Yeah.
think they're the owners of the same resource. None of them knows about the other one.
Yeah.
So in this case, like it depends on what we wanted to do. Like I said earlier, there's two reasons for moving. Well, at least two reasons that I can imagine. Oh, one is performance optimization. One is plain error, right, in code. Let's say this is performance optimization thing. Let's say we actually wanted two copies of this thing. Now, I don't know why we would implement it this way. Maybe this integer, like maybe this memory, this chunk of memory has a value and you want it in the other resource. Like the
Mhm.
way to make this a deep copy rather than shallow copy is you have a thing in C# and C++, I think, a notion of copy constructors, right? Yeah, so the copy constructors exist in, I don't know since when, but certainly before C++11. So it would be, I would implement it by saying resource. So this would be another constructor that takes another resource const type that takes another resource as an input. And what it does is I will now instantiate p. Oh, I can't do that because that would be the same thing again. Now what I need to do is I would have to create a new p again. So this is where this is how it differs from copying. Right? I will take the other resource, but I will create my own chunk of memory. I want my own copy of memory.
Mm-hmm.
What I do want to take out of the other one is just the values. So I'll say memcopy, it's a function. And how does it work? Oh, destination is first, source is the second. So I'll say, okay, destination is my pointer, and the source is the other class's pointer. And
This is R, isn't it?
yeah, I usually name them R, and then I just reverted back to muscle memory. And max count, well, currently I know it's 1,000, but this is where the problems start. Right? Okay, so now I've implemented a copy constructor. Right?
So we
And
create a new array,
yeah,
but then copy the data that was in the other array to this array. So we now have two duplicates that are independent of each other.
yeah,
And we
entirely
also
new chunk of memory.
yeah.
I just take the data from the old one and copy it into this one.
Mm-hmm. So we pass to the copy constructor. We pass this by reference, so an alias. We don't pass it by copy because this would be quite recursive, wouldn't it? Because then we would call
Yeah.
the constructor that this is always, so the copy constructor always takes a reference.
What does it do actually? Yeah, must pass its first argument by reference. Yeah, so you were right. Yeah, it is like good observation, because then you will just recursion.
Yeah. So in C#, well, there is if I assign a value to another value, yeah, then it will be copied. If it is a struct, then all the fields are copied. If it is a reference type, then just the reference is copied. But I can't have my own. I can't overload like equals operator. I can't have my own copy constructor. Well, I could have a constructor that takes an instance of the same type of a different object, but then I still need to call new. So it's rather explicit than implicit.
Oh, you still have to call new.
In defining, yes. Oh. So I can't really overload the assignment this way.
Oh, okay. Yeah, well, like you've seen earlier with the shallow copy, the C++ will do the shallow copy for you as well. But of course, it can't know what you meant with it.
Mm-hmm.
So maybe you meant to copy the pointer because this is pointer to a common, let's say, like data storage or something, and you want to read from it, and you want both classes to read from the same thing. Or in my case, I don't want access to the same thing because I'm deleting it. Again, the concept of ownership. That would be somebody else would be the owner, and I would be like not an owner. Somebody else deletes it. I just read it if it's still available. Right? In my case, that's not the case because I wanted to demonstrate the problems with it, but it's perfectly valid to just copy the pointers. And this is why I say like compiler can't know what you meant. Yeah, although there are hints, like you could just see like that you're calling delete in the destructor and this is a pointer, and there's nothing implying that this is the owner of that resource. So compiler could get some hints and could probably display a warning, like if anyone wants to assign, this is possible bug, so why don't you take care of it? And this is where I think C++ is lacking in tools quality. Although I've noticed that recently it's gone up. Like there are tools and static analysis and stuff that will tell you a lot of information about what might be wrong with your code. But I still see like C# as being superior in that regard. Like you can start with Visual Studio not knowing anything about C#, and Visual Studio will just through its warnings and like error messages from compiler, you will learn a lot, especially if you have ReSharper installed, then it's even better. Right? After 1 year of monkey like playing on the keyboard, you will learn C# eventually because it's informative. C++ just lets you die.
This reminds me now of an was it an interview or a talk from John Carmack at a QuakeCon, I can't recall which year, and he talked about his he really enjoys his C++ programming more and more since I think when they started into Xbox development, they got some development kit and Visual Studio, and the ultra whatever the best most expensive version of, and that included a lot of analyzers and a lot of
Mhm.
warnings, and he said he always does warnings as errors,
Yeah,
and yeah, letting the compiler help me write
yeah,
write
exactly.
the right thing, and then also if I write what the compiler knows, then again it can optimize
Yeah,
it significantly.
yeah. It's kind of like it was similar to my point earlier. Just tell compiler tell
Yeah.
compiler the business logic essentially, and let it handle the optimizations rather than you. Work with compiler. It's really good. It'll help
Mm.
you. It never needed to be complicated. Yeah. Yes, maybe in like C times in the like
Right.
1980s when there was no C++ yet, and this is an address. This is how you increment pointer. It was probably like harder at the time. It's not anymore. Like the C++ has evolved, C# has evolved, tooling has
Mm.
evolved. It's all so
Yeah.
much better. Just work with it, right? Don't try to be too clever. Yeah. So anyway, let me go back to this. So resource taken by reference, because otherwise it would have to call the copy constructor again, as you
Yeah.
cleverly
And
figured out.
and
Yeah,
now we have two independent copies of
yeah.
that resource that can be safely deleted independently because
And I
they
proved this by
own each
running.
other's data.
Yeah. And you can see how one
Yeah.
address is about 1,000 bytes, about 4,000 bytes later. It's not an exact number, right? It's just from the top of my head. And so this is G++ does something better than Microsoft compiler, because when I tried this in Microsoft compiler, it like before I added a copy constructor, it actually like did a runtime exception because it was trying to delete the same memory address twice.
Ah. Hmm. So does
For whatever reason, G++ didn't do this for me.
this is what we talked on in our preparation session. Yeah. Oh, only delete once.
Yeah,
So it's
for
a bit of a compiler implementation detail how this is handled.
I'd like to say yes, but I'm not confident enough in my
Mhm.
knowledge.
Mhm.
I don't know if this is a rule I missed or something, but I think you should not be deleting the same memory twice. No,
Mhm.
it's not down to my knowledge. Of course, it's wrong because like one of these objects could be deleted now, and the other one could be deleted in like 10 minutes. In the meanwhile, this memory could be repurposed for other means, and then you get crazy bugs later on. And every time
Mhm.
you try to reproduce it, something else will fail. This is what C++ is also famous for. Right? Weird bugs that are hard to track down. It all stems from mistakes like this. Like when I allowed my code to clear twice on the same memory address, this was like a latent bug. It was waiting for it to happen, right?
Yeah. Mm.
But for some reason, the C Lion plus G++ compiler didn't result in a demoable error before. But now it's moot point anyway, because now I have two memory addresses. Right?
Mhm.
And if I've done this line correctly, and I won't demo this because it's just going to take too long, it would also copy bytes from the values from one memory address to the other. So I would have a copy of the memory values, which is probably what I wanted in this line of code, right?
Mhm.
So this solves the problem of like memory management problems, right? It's now deep copy. However, it might not solve the problem of the performance, right? Maybe I don't need the R1 anymore. I just need it to pass it into. Now, where this is most meaningful is imagine you have a function that just wants to receive some data from you. You don't need that
Mhm.
data anymore. Like you just have to craft it to pass it into a function. Um,
So that does this mean I pass with that? I pass ownership.
Yes, that's exactly what it means. Yeah,
Mhm.
so let me write such a function just in case. So it would be, I like to think of these functions as sinks, because it's
Right.
like a sink. You put it in. Now it's not yours anymore.
Hmm. Hmm.
So let's say I do sink and I resource R, and in this sink I want to see out the resource pointer and end line, and that's it. Sink R1.
I think, yeah.
Ah, yeah, of course. Let me just fix this by deleting code, which is yeah. So you can see how it created a copy. So the first C out was here, and it was on a copy. And
Hmm.
second C out, the second output to console was here, which was on the original. But I said I don't need original anymore, right? Maybe this is a sink. This is where I had to craft a resource for sink to work on, but I don't need it after this line anymore. In this case,
Hmm.
it's a performance pessimization. It was a word I learned.
Yeah, see, because CLAN shows an icon that I also know from Rider that there is an implicit copy going on. So the
Yeah.
copy constructor is called, and we create the same data yet again.
Yes. So how do you go about this problem? Right?
Or we
And then
pass it
there's this
to a
whole
ref or something.
you could pass it by reference. Yeah, this is a good way to for the performance optimizations, but
Mhm.
you still have the handle to it from both sides of the code.
Ooh, yes. Now we have two owners of it. I see. Hmm.
You still have two owners, right? Of
Hmm.
course, the reference won't be cleared, right? But you can get into a problem with dangling references. So let's say this
Hmm.
sync stores it onto like some other object somewhere, and this function, let's say it wasn't main. Let's say this exits and the resource is destroyed. Now that other is
Mm.
holding a reference to an object that has been cleared. So it's again a memory problem. So it like references solve some of the issues, but not all of them. They solve the performance issue, but they don't solve the case in general term, because
Hmm.
it still allows you to do that. And also they don't solve the issue of when the copy is an error outright, like copying a mutex. Right? You're supposed to create new mutex because that means something on operating system. So the C++11 came up and they said, you know what, let's give that child an ability. Let's give programmers the ability to move an apple to the other hand without, copying first and then destroying the other
Destroying
one.
the other one.
Right?
Yes.
So the way you do that is via move constructor. Right?
Ooh.
Move constructor. So the way you do that is resource ampersand r. Now this notation was not really well accepted by everyone, because you know how in C++ you have a pointer, which is an asterisk.
Hmm.
Right? But then you can have pointer to pointer, which is asterisk asterisk.
Void
And,
star star. Yes.
yeah.
Hmm.
Analogous to that, you have an ampersand, which means address, similar to how
Hmm.
pointer means address, but different. And then they had ampersand ampersand, and the people were just thinking, what is this, like a reference to a reference? Well, a reference doesn't mean a pointer. A reference means alias. Right? So this would be an alias
Hmm.
to an alias, which is
But
just
that's
alias. It
it's
doesn't
done.
it doesn't
Yeah.
continue. Yeah. So this is why some people felt this notation is a bit awkward. And also there's some complication with generic programming if you want to use move constructors and like moving in templated code. Google perfect forwarding if you want more on this, because otherwise we'll just sit here for 4 hours.
Well, this is actually this would be a future episode. We will take a look at generic slash templates and such. Oy, oy, oy.
Oh wow,
um, what was again the
perfect forwarding.
perfect forwarding? Okay, this will be my good night read for tonight.
Yeah, just choose resources. It's like CPP reference is amazing, right? But you already need to be an existing expert in order to understand it, which I think it's gonna defeating some of the point. Okay, so are you're now googling perfect forwarding, right? Because
So yeah,
that's the name.
I can only feel standard forward. I see some Stack Overflow
STD forward.
articles.
Yeah. So
ST
it'll decide for you whether it should forward some variable as a reference or as a R value reference. So should it move or should it pass it as a reference?
So the forward decides that.
Yeah.
Does the forward do like some reference counting for that and knows if nobody else holds it,
Oh,
then I can move it. Otherwise, I can't. No, I don't get it. Okay.
yeah, it's a big topic. Yeah, but if you want to read it in a concise way, read this page.
I'll put this up for later.
It's not guessing. There's no cleverness to it. When it's clear that it needs to be moved, it's moved. When it's clear that it needs to be a reference, then it's a reference. There's no
Is there an
magic.
example? Is there an example where this shows the two different? Because I can't really imagine it. Also, my
So yeah,
templates.
okay.
I never really did template programming in C++. I'm not sure if
Oh,
I
that's
can
such
read.
a vast and wonderful field.
So
Every
do
time I
we?
want, okay.
So does it mean? So again, we have here. Is this again a copy constructor? No, that's not a copy
This is just a
constructor, is it?
function. Yeah.
So functions can also take ampersand ampersands.
Yeah.
What does this mean?
The same.
So we pass. Does this mean then the caller is invoking the move constructor?
Yeah.
I see.
Yeah, there's like no fundamental difference between member functions and freestanding functions. And the constructor is, okay, I don't want to say just another function because I'll make a lot of C++ devs angry. They're looking forward for ways to show me wrong. But it's, it's just a function, and functions can receive R value references, whether it's a member function, whether it's a constructor, or whether it's a freestanding function, or lambdas, or whatever. This is just something that exists. It exists like a reference did before, or pointer. There's nothing special to it, apart from it being new. Right? Some functions can do that. And yeah, templating, like when you see a template code with this ampersand, it's more complicated. This does not necessarily mean R value reference.
Not necessarily. It says down there in some cases. So
yeah.
I'm not sure if I can. No. So if we, I'm not sure if I can read that. No, I can't. So we define a struct. We define a function. No, I don't.
And to overload, to be honest, I don't fully understand this. Get. So, and then there's an ampersand after the function signature.
102. I don't get that. But it seems that in the first case, call this to overload is R value, and the second get would be an L value.
So when it's called in a, okay, so this is like different contexts, and I learned about this when I was, okay, it's easiest to explain in a Boolean. So you know how sometimes there's a Boolean context. So if you say if, and there's something in between the brackets, what's in there is a Boolean context. If you write 1, it will not be considered as an integer. It will be cast into Boolean because the compiler knows this is a Boolean context. Right? And this way, like you have two gets. Like I'm not entirely clear how to explain it with ampersands, but you could have a get that is const and a get that is not const. And now if you're in a const context, like if you have a const object and you're calling get, the compiler will decide to invoke the const get. But if it's not a const object, the compiler will decide to call the normal get.
Mm.
depending on which context you're in. And it's analogous to how compiler knows if you're within if brackets, and that's called a Boolean context. It'll do something differently than if you say int a equals 1. Or maybe the better example is like 2 is also true. But if you say int a equals 2, it won't decide to assign true to a. It'll assign 2. But if you say Boolean a equals 2, it'll assign true. It's now a Boolean context.
Depends on the context. Okay, so this is not ambiguous. The C++
No.
compiler can disambiguate depending on the context which function to call.
Yeah. It's all
Ah,
very predictable. It's very
cool.
predictable all the time. There should be zero magic happening.
Mm-hmm.
That's one of the features. It's not a bug. It's a feature.
Okay. I guess, yeah, in the future episode we dive into templating. I guess this is an entire rabbit hole on its own,
Oh yeah.
isn't it? Yeah.
Oh yeah. Like, do you have a week? Like I haven't even explained move, and it's already what, an hour and a half.
Then I jump back to your screen.
Okay.
Implementing the move constructor.
Yeah. So ampersand.
Mhm.
Long story short, this means it'll require the object to be moved into this rather than just being passed as a reference or as a copy. So that's why it's called a move constructor. So in a move constructor, what I can effectively do is I can say P equals the other one's P. I just stole its resources, right? Like, and now
Mhm.
the astute observers among you would say, didn't this class just steal the resources from the other resource class like you did in a shallow copy, right? And to an extent, that's true, right? So now thinking, what did they fix then? What they did fix is I can say r.p now in the next line is null pointer. So I can signal to the other class, well, to me, that this isn't, that the pointer doesn't, it doesn't exist anymore in the other class.
Mhm.
So I took over, I'll put it into different lines because why not? 2 statements, 2 lines.
Mhm.
So what I did is I steal the pointer from the other class, and then I assign the other class's pointer value to null. Now, why didn't I? Okay, a trick question for you maybe. Why didn't I just delete it here? Why did I assign it to null and not delete?
Well, wait. Oh yeah, yeah.
Maybe
Okay.
maybe this is too soon. You still don't have the entire information, so it might be too soon.
Well, we may be deleting twice then, because if we still keep the delete down there, now the the um the value that was moved from
Yeah,
still exists but doesn't have ownership
yeah,
anymore. But at the end of the scope, it will be deleted, so we would
yeah,
delete twice.
yeah, exactly. That's entirely correct. Yes. So this is why I assigned it to null pointer, because, and this is the difference between shallow copy and moving, right? In shallow copy, the original is unchanged.
Mhm.
In this moving, the original does change. Like
Yeah.
I deleted the other guy's pointer, but the other guy has the same destructor that I do. So this destructor now needs to cater to the different things. So after the object was moved, it was supposed to be in something called like what's the legalese for this sort of thing? It's like in a valid but unspecified state, something like this. It's valid but unspecified state is the expression. So pointer being null is still valid, but now from the outside it's like in unspecified state. You don't know what this pointer is. You can't rely on this object behaving in any sort of way. However, within this object, I still need to know if I'm
Mm.
deleted or not. So I'll say if p equals null pointer, which I'll probably promptly be corrected by compiler that I could just say not p. Is that true? Oh, deleting null pointer has no effect. Oh, in fact, it's even safe. I just learned this.
To-
Today I learned. I didn't even need to say if.
Oh.
Okay.
Okay. So the GCC compiler doesn't delete null pointers, or doesn't try to
I
delete
don't
null
think it's
pointers.
down to compiler. I think this is just C++ that
Okay.
I learned while
No, wait a
teaching
minute.
C++.
Isn't this the other way around? So if it's a null pointer, then we delete. Shouldn't it be if it's not a null pointer, then we delete?
Yeah. Correct. But the if is still unnecessary. It
Okay.
seems like if P is null
Cool.
pointer, then whether I delete it or not has no effect, which is
Mhm.
different to my previous case when it still had some value. And if I deleted it, I would delete who knows what.
Yes. Mhm.
However, I would like
Mhm.
to keep my check in just to demonstrate the point how if you move away from the other resource, I can signal to myself because the other resource is of the same type. So I can work with this. Like it's all enclosed still, it's all encapsulated nicely. I will just set this pointer to null pointer. And then in destructor, I can see whether I was deleted or not. Now there's this little error here because in the debug, C++ will set your values, but in release mode it won't. So it might be that this pointer might have a value, might have some value when it comes
I
to
see.
delete, and then it wouldn't be null pointer. So
Mhm.
what I've done with this little case is as soon as resource is created, the pointer will be null. It can only become not null. It can only become something either through its own constructor, or if I'm copying it,
Mhm.
or if I'm moving it. Right? The problematic case here is moving it because I need to take care of the other guy's pointer. Yeah? And I do that by setting the pointer to null. And now that other guy's destructor can be called safely because it's been signaled. This is the valid part of the valid but unspecified state. Like it still needs to be valid thing. Like the what's it called? What's it called when you need to keep like a couple of values work together? It's not encapsulation. Is the I won't remember the word now. No, can't. Like both
Okay, what you
destructors
mean?
will still do the correct thing, right?
Yeah. So they're independent. So now I have R1, but I pass that. So the main method then passes it to the other function, and this is where we move the apple from one hand to the function, and now the main method doesn't hold the apple anymore, so
Yeah.
it doesn't need to delete it because I don't
Yeah.
own it anymore. I passed responsibility.
Yep, that's
Mhm.
correct. And I can signal this, like if I'm writing a sync function and I want to say to users, this is a sync function, you should not use this resource anymore. I just do the double ampersand. And now this is a compilation error because R value reference cannot bind to L value reference anymore.
And R value cannot bind to an L value.
It can't happen by mistake anymore.
I'm not sure if I get that right.
Okay.
So we,
So
which one is the L and which is the R value?
Okay, the error message goes with R values and L values, which I haven't totally explained yet because I wanted to make clear what move is. In this case, like this will be an R value. Not true, but let's work with this. Right? This is an R value, yeah. And R1 is an L value. Like I can assign stuff to it. This has identity. Okay, this is how I started. This I could take address of this. So stuff that I can take address of can't be moved into syncs. They can, but it can't happen by mistake. You can't just, yeah, because I could have another thing that would take a copy, for example. It can't happen by mistake. What you need to do is say explicitly move, right? And then from the inside of the function, if you only see this part of the code, let me do this. If you only see this part of the code, you know that you're taking over the ownership of this resource, right? Also, on the other hand, if you, okay, I need to scroll down a bit. I'll just close this. If you only see this part of the code, you know I'm giving up ownership to this function. So whichever code you look at, you're pretty clear what's happening here. And this is why they made it so that R values, this kind of R value can't bind to L value easily. You have to cast it, you have to move it. This is the move operation that does it.
That's moving. So that now means in line 33, accessing the thing that I just moved, that's invalid or unspecified behavior now.
So remember, the object is still in a valid state. This isn't an error like syntactically, but it's in a like invalid, but what did I say before?
Invalid but unspecified?
But unspecified. Yeah. So I shouldn't count on this object behaving in any particular way.
I see. Yeah.
So it's safest not to use it at all. Just don't use it. In this
So
case,
after moving, I forget about it, and all is cool.
Yeah, that's the intention. You forget about it. You forget it ever existed. And in fact, the Visual Studio was better with this than Sea Lion. And maybe this is some like checkbox that I didn't find to tick. But it actually, when I ran code analysis on this exact problem, it told me that R1 is being used after it was moved. Have another look and see if it's a bug, right? Sort of like the tooling helping me. The C line doesn't say that, but like technically it's not a syntax error. Like you can do this. It's just yeah. Don't count on this object doing what you think it will do. Right? So now if I run this, so
we still pass it by
did
reference?
I not? Did it pass it by reference? No, it shouldn't, because move won't
this should
pass
be
by reference.
So after the move constructor, it should be nulled?
Yeah, the other one should be null. Didn't I just assign it? So if I say, oh, it's not F11 to trace into, is it? What is it? How do I?
I only know the Visual
It's down here.
Visual Studio keyboard
step
layout.
Into. F7 is step into. F8 is over. Okay, if I step into, yeah, I'm in. You didn't step into did it? Okay, I need to debug this thing again.
While you're debugging, excuse me?
So I'm trying to now see if it stops in the move constructor. I expected it to stop in the move constructor, and if it did, this pointer should be null. And in the end, when it displayed both things, I still got the same address twice.
Yeah,
as if I didn't. As if I didn't move it. One is. Did I forget any of the variables somewhere? So I have one resource. I move it into sync. This code takes over after being moved. Do I need to? Yeah, maybe I used the ampersand too much. Let me see if this helps. Yeah, now I'm in here. What did I do wrong? What did I do wrong? I actually can't explain it. I don't know why they do wrong. I'll figure out later, like 5 minutes after we end this chat. It'll be all clear. Right now, I can't reason my way through it. So by move, I told it now you should move this object, and this now isn't a copy, but will actually be like a moved thing. And with that, it now did stop into the move constructor, as you can see. So if I F11 through it, now this got the same value. The other one will now get nulled. And when I get back to this place where I was, and then where do I have console? Yeah, the first pointer was something. Now the R1.p was null. However, like I know this because I implemented the class. If you're dealing with some library, at this point you should just say, I don't know what it will be.
Yeah.
I
see.
shouldn't even, you shouldn't even read it. Who knows
They,
what's there?
they could point to something again, which I may not. And this is exactly what Kevin is, by the way, thank you much for watching, is also pointing out what he dislikes about C++, because this shouldn't be, even if tooling would do a warning, this even should be a compilation error in their opinion.
I don't know why they didn't make it a compilation error, to be
Hmm.
honest. There's probably a reason. Like every time I think something stupid, and then I go to some conference and the guy clearly explains why they couldn't do it. And like more often than not, it's a clever reason behind it. So the fact that I don't know what the reason is doesn't mean there isn't a good reason. But yeah, I mean, it could be a compilation error. In certain tools, it displays your compiler warning. Like if you switch on warnings as errors, you've
Yeah.
effectively arrived to that destination by other means. So I don't see it as such a problem. Like as soon as you know that, like after move, you don't use it anymore. In practice, in my experience, it wasn't a real issue.
Mhm.
Like, but okay, even if let me just clear my throat. I just stop mute so that I don't scare everyone. Like even if this was an issue, for example, like consider what we've just fixed, right? We've avoided all the possibilities of like getting errors with this, right?
Yeah.
Because also we did performance optimizations. We don't need to create new chunk of memory and then copy the old memory out of the old thing and into the new thing, right?
Mhm.
And
So
also it's clear who the owner is.
yeah.
And
So
also,
excuse me.
okay, this will like blow your hat off. So okay, I moved R1, but let's say that before I moved R1, I still wanted to copy, like into R2. Like I can do that, and because I still have copy constructor, I can
Mhm.
say equals delete, and this way I now deleted copy constructor, and copying will become an error. Attempted to use
Cool.
deleted constructor. Now this would be the case, for example, with mutex. Now I've made sure that this resource is never copied. Either you create
Mhm.
a new one or you move it, but you can never copy it. Right? So this now deals with not only performance optimizations, but also the case where something is just error when it's copied. Like, so
Oh,
I
this
think
is
like
really cool.
getting all that for the price of like if you use it after, like you really shouldn't use it after. I think it's on balance, it's useful. Right?
And now, so it is really, so it's a lot about ownership, but I can move
Yeah.
ownership. But then I definitely yield it. I'm no longer.
Yeah.
I could, but I shouldn't. This now reminds me of an example in my. Well, I made some mistakes, and yeah, time for some embarrassment. Switching over to C sharp, I guess this kind of explains a bit of a move semantics. Although we don't really have that, or at least I haven't encountered that yet. So the example that I went into at some point is having a memory pool here, using the shared memory pool, where the implementation under the hood is just an array pool in the .NET runtime. You can rent and return to that array pool. But when you rent something from that array pool, you should be the only one who has ownership of that. There shouldn't be somebody else who still has a reference to that shared rented array, because they could totally assign values in my array that I wouldn't expect, or clear it, or something. And so I'm using here this abstraction. I'm renting some memory that has at least a size 10. So at least 10 integers, could be more, depending on the implementation. And then I just want to print what is in this memory. So we really get a memory owner. That the name really specifies that, okay, there is something to be owned, and actually then also yielded back again. This print method is now, we are the memory owner. We can actually get, well, there is a memory and span, where the very interesting point here is the span, which is just an abstraction over contiguous memory. This could be pointing to an array. It could be pointing to stack allocated memory or some native memory that I actually have in unsafe code a void star pointer off. But this is a safe abstraction over it. And I have also a print function that just prints out the values, and I want to fill that span, or well, during runtime, since I'm using this shared array pool under the hood, it will be an array, then just filling it with a number that I pass in. And I print it out before I filled it and after I filled it. Let's call it before and after filling. And yeah, when we just run this, we see we get in an array or some memory of at least 10, and we fill it with 1. At the beginning, it will be all zeros. So we request at least 10. In this case, we get contiguous memory of size 16, and then we fill it with 1. Then we can do this again. So I just rent again. So, well, between I also dispose. This is now the act of yielding, of returning it. The implementation now will, actually, let's take a look at the implementation. There it is. So when we create this type, well, we don't really see this type, that's private, but we get a handle to that via that interface. We create it where we just rent an array from the array pool. And yeah, via memory, we get this. We don't get the array directly, but a view of memory instead. And when we dispose, we just return to the array. And we also have here the similar semantics that you showed. So when it is disposed, we actually null the array, so that when we dispose again, we don't return that array again, because yeah, you should. I guess that would be the create and delete semantics. You should only return an array to the pool once. This could cause undefined. Well, I guess is it defined, but it could cause weird behavior. And yeah, so I'm disposing, then just renting another buffer of at least size 10. Since this is returned and I'm requesting the same size, it's very likely that I actually get the same array. And then in the second step, I want to print it with, fill it with all 2s. So we now see in the second step that we actually get the previously returned array if it executes. So we see in the let's
just got recycled memory back.
Yes, exactly. So before the filling, we still have the ones from before, and now the new, we fill it now with 2 with the next call, because we were diligent with the disposing. Now, what if I would? But I'm kind of passing the real owner here. This is something could be dangerous, because now this print method now actually has the owner, and this print method now could actually, maybe I want to have like the same move semantics. Maybe I assume, okay, let's call this actually sync. Like, oops.
Yeah, sync is all right. Just sync.
This overload sync. And let's say I want to have the same semantics, and I want the sync now to take care of returning that array to the pool. But what if I cheat a little and I still, in the meantime, get another reference to that memory? Keep that, then pass the ownership, but I still keep that, and maybe now do a fill here myself, fill it with all 9s. And we see now that the second call now gets, well, again, the same array after returning, but we still, it's now no longer, this part has sole ownership over it, but we have somebody else owning it as well. And yeah, this is definitely a mistake. And since code that I saw and maintained so far is usually that you really don't pass ownership, the method that creates it, or if it's contained in a type, the type that creates it is also responsible for disposing, returning, deallocating, whatever. And now actually we talked about there could be since, well, it's all about idisposable. This is the deterministic cleanup in .NET. What there could be is maybe something like an analyzer. So if we pass a type that is idisposable, maybe we call this we pass on the move attribute. This doesn't exist, but we could have an analyzer. This is a to-do for a future project, a Roslyn analyzer for .NET or for C# language now, that once we pass the ownership, now using it afterwards. So if we were to, well, I guess it's still difficult to detect that, but if we were to use that afterwards, now this should be a mistake because we passed ownership here. And just like with the move semantics, we should not use that anymore. And this is now why I want to implement that analyzer that offers the move attribute.
Sorry, I died there for a second.
It happens. So, okay, in C# we don't have to move ownership, but we still need to be aware of moving the concept still exists of who owns it and who is responsible for cleaning it up. I guess most of the time it's easiest when the one who creates it is deleting it. When it gets intertwined a little bit, then it becomes difficult, but also difficult to argue how to go forward now.
Also, like in this case, okay, well, in C# at least you have like garbage collection and this thing that like oversees all the objects in memory. You don't have that in C++. So each object, like each type, is on its own. So the errors can still be if you don't implement your move constructors correctly. Like I could have failed to assign that pointer a null pointer thing, or I could have failed in destructor to like pay attention to what I'm doing now. Right? I can see how like okay, in C# maybe this I own a memory, or what's it called? What's it interface
well, this
called?
this is one example, the iMemory owner.
Yeah, iMemory owner. Like maybe it's just that thing that's not defined correctly, because it knows like after the sync it was disposed. So the other memory is still it's essentially the same object. It's not even a copy. Could know I've been disposed already. I won't clear again.
We still have now we have two references pointing to the same thing. I guess to draw it a little bit easier, since there's just an abstraction over it. When there's also what's usually using actually under the hood is the array pool. So if we array pool, let's do an integer array pool again. The shared pool. You can also create your own pools, but there is one shared pool that now the entire application can share. And we can rent from that pool. But now we just get arrays. The memory pool shared is just an abstraction via the iMemory owner to also add to not only add this idisposable over it, but also use the newer model of memory and especially span. Because if we have a span, actually that this shared, or is it there, that the shared memory pool is using an array pool under the hood is just an implementation detail. All we know, it's some memory and some span, could be anything. And now in this example, it becomes a little bit more clear. So we rent something from a pool, we definitely need to return it. And return. Oops, return. There we go. But now after returning it, we shouldn't use it anymore. Or do anything with it, like
what if you try? Is it a
assigning something
error?
to it? No, it's not, because I guess that's difficult to track because, I guess you could build a special this is not from a C# perspective. That's valid C#. What you would need to have is a compiler, a Roslyn analyzer that understands that this array is coming from this array pool or from any array pool and was not manually newed, and therefore, eventually should be returned, and after returning, not used anymore. Maybe I don't have all the analyzers enabled. Perhaps there is actually one. I need to Google that quickly. I see Googling, but do Binging. .NET code analysis. There is, because per default you get some analyzers enabled, but not all of them. But you can actually, but I always forget, enable more rules. Yes, so let's enable all the analysis mode. Oops, all.
Copy
Maybe it
pasta.
actually, let's see. Forget any diagnostics. Oh yeah, move attribute doesn't exist, of course.
Yeah, figment of our imagination.
Oh no, those are, because I'm not using, those are different warnings. No, those are different
Just
warnings.
scroll up and see if it's underlined.
Oh no, those are just style inspections. So no,
I guess
there
it
currently
kind of
is
makes
no
sense.
analyzer.
I don't even resent that the tools can't do it easily, because in general case, I can imagine it's a difficult problem. You could pass this ABC into something which would pass it to another DLL, right? And then it comes back as a number, like the address is a number. But what happened to that address? Maybe it happened shed.return. And for the tool to realize this, I think in general case is really complicated. In this case, it's not, because 2 lines above you have rent, 1 line above you have return. So it looks fairly simple. But I think like if you're trying to design a tool that will work on in general terms,
Yeah,
bet it's a different problem.
I guess flow analysis in general is tough.
Yeah.
Cool. So that's moving. How does this tie in into the L and R values that we talked earlier about?
Oh yeah. So it complicates the entire picture, right? So if you switch back to my thing, so I'll try to use this blackboard feature for a while. So now I've demonstrated how you have stuff that has identity, right?
Mm-hmm.
And you have stuff that is movable, right? So in the identity was the sort of int a part of the expression, and movable is the 5 part of the expression. And this is how it used to be. So the identity was called, what had identity was called L value. Now I'm drawing a wrong diagram here because it's not that simple anymore, of course, because the C++ people came around. And what was movable was called R value.
What we saw, like in the first example, we moved the 5 into
Yeah,
the
yeah,
field or into the local that has an identity.
yeah. So let me go back to, keep getting confused on which screen I am. Okay, throw this out of the window for now, because we've just created a thing that has identity, but it's also movable, right? We didn't exist before C++11. Remember, now we have like move constructor, and with move resource, I could essentially move the object into the function, and it like essentially didn't exist in the original, like outside of that function that worked as a sink. So this weird abomination now has properties of both. It has both properties. It has identity. It clearly had an address in memory before, right? And after, but let's forget that, because afterwards it shouldn't matter. But it was clearly able to move as well. Like it didn't need to be copied. I didn't need to create a new chunk of memory and copy the bytes over, right? So it essentially has properties of both. And this was in the new world. They didn't really know how to name it and just called it X value. So when I said earlier, it's a strange R value. I said it's R value. It's not, but let's work with this. Right? It was an X value really. So because they had no existing ways how to name it, they kind of said X, and it was supposed to mean like mysterious or cross between both properties, or just the central value, the X value. I've read the cppreference.com earlier. Apparently, it means expirable value, which is probably the worst choice of what it means. Like,
Expirable.
yeah, like because it expires. Right?
After
So
moving,
this is
yes. Hmm.
yeah, because inside the function, it was like fully completed object. It didn't matter how it got there. But before the function was called, it was also like object. In the meanwhile, during that transition, it was this expirable value. It like existed for a while and then it didn't anymore. Right?
Hmm.
This is abstract. This isn't like a line I can point in code. Right?
Hmm.
So I think this is the reason, this is the rationale why they call it why they say now that X stands for expirable. I still think it should be either cross value, right? Because it's cross between the both, or like mysterious, like in X-rays, like a mysterious kind of new values that came with C++11. Like the other two would be easier to explain. Like so, the things that only have identity but are not movable. Like I don't want to write. I want to write. L values are called L values in today's money. But the things that are movable but don't have identity, like 5, right? So they saw it as a like a pure R value, an R value that doesn't that's like well pure. There's nothing else to explain here. So they call it PR value. So effectively in C++ code, you're not dealing with L value and R value anymore. You're dealing with
Hmm.
either L value or X value or PR value. Now, maybe I should give examples so that it's easier to understand. So the L value would be something like int A or something like, okay, int, what I also did was B, which we like assigned A to it. And also
Hmm.
what I can point out now, this is called value categories. But even in this, like, it's a mistake in the first word because the first word is value, but this is really about expressions, right? So expression belongs to a value category, not
Hmm.
a value itself, right? So let's say I did like this, right? So this would be an actually I don't know what this would be. I'm trying
This
to
is
say L value, but this address doesn't exist anywhere stored in the memory, does it? So the address itself doesn't have identity. I think I just painted myself into a corner.
the ah.
Yeah, so
Is this
A has
I'm getting the
identity, and this is the way to get identity out of it. But identity itself, like the memory address, at this
yeah.
point, it's not stored anywhere. You can't change it. It has all the properties of not having identity, right?
So is this now a pure R value?
I think it's a PR value, but I'm not sure. Like I think it's a PR value, and
Because
this
you
is
could
why I
move
said
it.
earlier. This is yeah, yeah, you could move it. It's what I said earlier. I struggle to explain this because I myself don't understand it
Mm.
fully. But I every time I'm trying to reason myself through these things, this is this diagram that I'm building right now. This is how I help myself. Does it have
Mm.
identity? Does it move? If both, then it's X value. Stuff like this,
Mhm.
right? Because thinking like this is it was easy in old days when you had right hand side of the assignment operator and left hand side. We're way past beyond that point. So an X value, for example, would be something like move A, right? So this is a
Mhm.
better way to explain how it's about the expression, not about
Yes.
the variable. Because in
Mhm.
this case, let me switch colors because I can. In this case, A is an L value,
Mhm.
but this expression is an R value, R value reference, so X value. Right? So move A is an X value, but A is still an L value.
Mhm.
This kind of demonstrates it's about expressions.
Expression, yeah.
Yeah. So PR values, for example, would be, now this is the simple case. It would be like 5 or, maybe we should change back to yellow. Yeah, I still need to learn how to operate this vehicle. So like 5, or let's say letter A, or
Mhm.
because it's an expression like A plus B, like this is a PR value, which might
Mhm.
surprise you, right? But it's like the result of A plus B is a number. It clearly
Mhm.
has value. It's movable. You can assign it to something else without creating a
Mhm.
copy. However, you can't uh, green green color. However, you can't say a you can't assign to it. You can't take address of A plus B.
Yeah.
If you see, it just exists for a while, and then it's
So
assigned to something.
this is actually in the first, does this connect with the first example that you showed, where you had a function that was returning uh, a plus b, and then the compiler was able to optimize it because this is something movable, and well, no, I'm now
Oh, the
conflating
compiler
two.
wasn't able to optimize this because it was PR value or whatever. Compiler was able to optimize it because it could somehow analyze that no matter what the input is, the output will always be 6.
Ah, right.
And then
Okay,
it
that's
just
two different.
replaced everything with 6. This is a
Mhm.
large trajectory of development of C++. Do as much as you can in compile time.
Mhm.
And this is it's enormous topic in C++, especially lately. You can even have
Mhm.
like vectors and arrays and like entire computations made just by compiler,
Mhm.
so that it saves time in runtime, like doing compile time whatever you can, so that in runtime it's faster. And what's faster than if you say A plus B, and it didn't even use the addition command from the assembly. It just returns 6.
Mhm.
That's the fastest. So where is R value in this picture? So they were choosing the names that would be compatible with how people used the expressions before, right? So what they say is we didn't mix everything up. We didn't destroy everything. We just added new, more precise terms. So the L value is still present here because this is how it was used before traditionally, and not just traditionally, also in C++ standard, right?
Mhm.
But then they analyzed R value, and they noticed that in all the cases where R value term appears in the C++ standard, they were really describing something that was movable, right? Not something that was like like 5 in specifically, but something that was movable. So this would also cases like this, if they ever appeared in the standard. I've never read it. I'll just admit it's too thick.
Mhm.
Um, the um, the intention was always describing something that was not always, but most of the time describing something that was movable. So they named the movable R value. Yeah, and
Mhm.
the stuff that had identity but was either movable or not, and this was a complication they added later after move started to exist. They saw this as this is a generic L value, so it can either be this or that. So they called it GL value.
General.
Yeah,
Now the now the R value, does this mean if I have a function call, is then, yeah, so the argument that I pass into the function is this, the expression that I pass into the function, that's the R value.
yeah,
So it could be a PR value, like I pass 5, or I move something into then the, yeah, I
yeah,
think I get it. Yeah.
yeah. And now just for a fun twist on this, somebody might observe that if I drew like the way I draw a diagram like this, it looks cool. But I do have like two things: identity, and I have whether it can be moved or not. And if I say, well, L values have identity but can't be moved, and X values have identity and can also move, whereas movables like 5s do not have identity but can be moved. So it's clear that there's like a combination missing, something that
Mhm.
doesn't have identity but also can't be moved. Now, why does this not have a name? I think it does have a name. I named it useless, and I like this idea of mine because imagine you're writing a program, and there exists a value that is useless.
Yeah.
Yeah, you can't copy from it, you can't move from it, you can't read it, but also you can't assign to it. So in fact, this is like it exists, but it's unreachable if it ever existed. So in my previous job, we joked about write only memory, right? Thinking of like, how you have read only memories. Like, what
Yeah.
if there was a write only memory? No,
Right only memory.
this thing is even more useless than write only memory, because you can't even write to it. Right? It's just what
Mhm.
exists only memory. So even if this exists, you might as well just ignore it. Right?
So because it just eats up space, but I could never refer to it.
Yeah, as soon as it eated up space, it would be like it would have a location.
It would have a location. That's right.
Yeah.
Okay.
So it's
Yes.
an abstract value that doesn't
Mhm.
eat up space at all.
Mhm.
Just like, I don't know in what way it exists, but it's not in memory. This- so yeah, this is why the graph is this way, and they're usually not presented in form of a like spreadsheet like
Identity,
this. Yeah,
identity, and movability. Mhm.
yeah.
That now that now makes me think of something. Yeah, we in the beginning we promised some shenanigans. Well, not sure if we promised them, but we talked about shenanigans and how you can shoot yourself in the foot.
Yeah.
Um,
So it starts with, if you noticed, I did say that A as a character is a PR value, right?
mhm.
But you'd think, well, a literal string is also then a PR value, but it's not. Like according to C++ rules, it's not a PR value because apparently it does have address. Now this address is a bit
Hmm.
harder to come by. Like you
Yeah.
can't just say literal equals some other string, it'll be a compilation error, but it's also
Mhm.
really hard to get address out of it because it looks like it doesn't have one. So this is
Yeah.
not a PR value, contrary to
Hmm.
every intuition I had before. And if I understand correctly, this particular problem shows up in C# world as well.
It does. Well, not really on a language level, but during the runtime. So we just have here a string and print. Let me again disable all the compiler warnings or the extra warnings. Let's keep the default. And yeah, we just get a string and we print it to the console, and there it is. But in C#, there is performance optimization because allocating a lot of strings would be expensive, and string literals, I think there is other cases as well, but predominantly string literals are interned. That means if I have the same string twice, it will actually be the same reference. And that incurs the contract that strings are immutable. You cannot change a string, because if I would have two point to the same string and one manipulate then the other, that would be really bad. And we can show that by doing here a reference equal. So if I do a reference equal of these two strings, those two string literals, they will actually be true. So they are not only value equatable, but they also have the same reference because of the string interning. They will be the same. So there is. So although I guess this also connects, although well technically we can't assign to it, uh, which kind of would, I would assume this would be a PR value, but at least at one time, it does have some identity. There must be something. We can also, and this is the string interning. So if we would now, there is a method called isInterned where we can check whether the string is interned, and it returns null if it is interned. No, it returns null if it's not interned, and not null if it is interned. So if we check that result, if it's not null, let's print is interned. We see that the string is really in the intern pool of the .NET runtime. Now we can do some fun. Well, technically, we can actually get also, well, a string is a UTF-16 string per default. Well, the string is UTF-16 characters in C#, and a single character would be a character. So we can also get this, what I mentioned earlier, the span. We could also get a read-only span. Read-only span of characters over this string. Let's do text. So this is implicitly convertible, and that's cool because a span, the read-only span, is immutable. We can't assign a new character to that, so the contract is still fulfilled. But you can do some shenanigans by converting this read-onliness array. I did build a dangerous type that has the span method. I now pass in the string, and I now do get a span view over that string that somewhere in memory has a location, has an identity. And we could now let's replace the spaces with exclamation points. So at character 3, we put an exclamation point, and at character 8. And now let's just print to the console the same string literal again. So we now print, remove the others, the string literal, the code polyglot to the console. But what we get now is actually, although we print this, we actually get those new mutated exclamation points because of the string interning. Now, this literal actually, or the same as these two literals, due to string interning and the intern pool of strings, point to the same string that says the code polyglots. But I did here a contract violation and added some exclamation points. And now this still points to the same thing. And the interesting part now is if we were to check reference equality between this text and the actual string literal with the exclamation points, they are not reference equal. This is false because they are different locations. We have now the code polyglots and the code, with the exclamation points, the code polyglots, where I just say address 1 and address 2 somewhere due to the string interning, but we manipulated address 1 with exclamation points, so they now look the same, but they are different locations. And this would be I mess with my coworkers mode.
So what makes them the same? What is the identity part here? Like, how would you define? It's clearly the same identity. When you say right line there and text equals there, like you change the text. You did not change the string literal. So there must be something that's the same to this. Did they live at the same address?
Yes.
And it's defined by the actual string.
It's I don't think that's a language thing from C#. I think I'm not entirely sure, but I think this is a one-time aspect of .NET, the performance optimization. So we don't, for every string literal that we write, we don't allocate a new string because, well, if they are the same and if they are read-only, they can just be, the reference could be repurposed. And so I don't think from a language perspective, but during the runtime, due to string interning, they now are. So this UTF-16 character sequence now actually has at runtime, not at compile time, but at runtime, does have identity. Yeah, and I guess there is a special. I'm not so sure about the garbage collector, but I think there is a special area where the runtime keeps those intern
maybe
strings.
this is the underlying reasons for both things. Like, if you just switch to my screen for a moment, I'm trying something out. So if I say code polyglots. Okay. Of course, I can't add one to it anymore. I just wanted to see it compile. Yeah, see, so what the binary file contains now. It's a
Yes.
literal string in the binary
Mhm.
file. And when okay, let me use it. Let me return it. I can't return it because main returns integer. Okay. Cout A. And I'm just using it. So at the time when I start using it, it converts to string first. I was trying to find a location where it refers like to line number 2 rather than like inlining it. So if .NET is compiling in the same manner, it must, like in the end, it's a binary file at some point, right? No, it doesn't need to be. It has this virtual machine on top or something, right? But maybe this is the underlying reason. Like this string is actually not scattered through, like 5 was directly inlined in the code, but the strings can be defined at the beginning of the assembly file.
Right. Yeah.
And then the rest of the program can refer to it. Yeah, you can move away from my screen. I just wanted to see you like compiled C++.
This actually, Kevin is pointing that out. So in .NET, the data is stored in the assembly metadata. So that will be the resulting DLL. The string is allocated in memory the first time you access it, and the GC then keeps a special handle to it so that it's never collected.
Oh, so that part is that performance optimization that you mentioned.
And interestingly, if you assign your string literal to read-only span instead of string, the span points directly to the assembly metadata in memory. Ooh,
you can do
cool.
that.
Let's give that a try. So if we now do, because that showed earlier, the non-dangerous implicit conversion to a read-only span. Now we can't mutate it, of course, because the indexes return a read-only ref. We compiled it. Let's go into the IL. And we don't, do we see that here? Maybe I see this in SharpLab. If we read only span of char text equals to something. Well, it doesn't show. Well, maybe when we take a look at the IL code, but I'm quite not capable of reading that. What I do know, however, there is also UTF-8 strings. So characters, that's UTF-16. That's 2 bytes. You can also have UTF-8 strings. For example, when dealing with JSONs, this is, I guess, one of the main use cases. So we can also get a read-only span of byte. So that's now UTF-8, 1 byte. But we need to add U8 there. And this actually gets, well, at least this is also what we see. Here we also see something emitted. Some compiler generated creates a struct with size 10. Do I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters?
Exactly.
And some address that then when we refer to the read-only span, actually then use, and we do some unsafe as pointer. But to get this also for the string, can I try the static field instead of a local? Static string. Oh no, static. Well, we can't have a read-only span. A static one, can we? What do you mean? So static string. Static. Do you mean like so? And then, no, wait a minute, what am I doing wrong? Oh, yes, it's read-only UTF-16 string again. And if we take a look at the IL, I can't read IL. Let's see what we see. Need to zoom out a little. Oh, wow. Okay, so here's the static field. Okay, now I embarrass myself because I really can't read IL. Trying
This
to
isn't what we're
find.
meant to do anyway. So to make you feel a bit easier.
Here we have the conversion, the implicit conversion from string to a read-only span of characters. Static field of type read-only span. Yeah, I'm confused. I can't remember the conditions of the optimizations. Well, we can't put a read. We can't have a static read-only span of chars, because read-only span, that's a ref struct that must only live on the stack, can never live on the heap, so we can't put this in a class. Can we put, yeah, where would it live? We can't put this anywhere, yeah. Because I guess
Must
it
be
needs
some trick.
it needs something with identity to be, that the garbage collector can track.
Identity. You said identity.
Identity. Oh yes, identity. but it does show with the UTF. With the UTF. With the UTF-8 string, I believe I can imagine that the compilers and such are very, very optimized for string, because that exists since forever. Maybe that's why it doesn't show. But the UTF-8 that's a newer UTF. I think this is since C# 11, so that's just 1.5 years
use an
old.
emoji. Use an emoji and watch everything burn. Yeah.
And there we go. That's the inline.
Nothing changed.
Inline assembly representation of an emoji.
Okay. That was not as fun as I expected.
Well, we tried. Cool. So it's all about identity and movability, or either one of them. Of the expression. Oh yeah, not the values, but the expression. Yep. Yeah.
See. The expression categories. Let's go back. You fix your initial graphics that says value categories. You change that into expression categories, and then we re-recorded the entire 3 hours.
So the real thing is it's value expressions?
Value categories, but it should be expression categories.
Expression categories.
Yeah.
We need to undo history. I guess that's more difficult on YouTube than it is in Git, but I'm not sure if I will use identity a lot, but I definitely use location, because I think this is what the C# compiler is also referring to.
It's the same.
I'll be using location a lot in my future.
Like I started this, I said like identity was meant to abstract all these other terms for the same thing: address in memory, location. Like this is on a tape, let's say a tape memory. This is actually like centimeters in, for example, like literal location. So this is all like identity was supposed to, in abstract way, encompass all these different expressions for the same thing. Can you point at it, right?
Yeah. One last try. Ooh, there is something. Okay, when we do it with... Oh, there is the... can we give it another try? When we have so this is now a static property that is only gettable. And we return here a read-only span of 1, 2, and 3. And because it's static, it's actually also emitted into the assembly, which also now means this expression now has an identity as well. If I'm using the same expression twice, will they refer to the same identity here? Yes, it seems they do. We only have one of these, but 2 of them. There is some one-time field handle that I'm not sure what the compiler does, but because if let's change 1 to 4. Yeah.
But now it's different things. It won't be.
Now we have 2 of them. Yeah. Oh wow, cool.
No, but it's read-only span, so you can't change it afterwards, or you can if you with your unsafe.
Yes.
Dangerous. Okay.
We could mess stuff. We could mess up expectations at one time dramatically. Yeah. So never cast away read-onlyness. No, 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 no.
Well, to be honest, you have to go like pretty far to make sure that you've introduced an error to the program. Right? This
Well,
isn't what it was meant to protect us from. It was supposed to protect us
yeah.
from accidental mistakes, not
Right.
like I'm going to break this thing. Of course you will. Like,
That's fair. That's a
yeah,
voluntary mistake. Yeah.
yeah. We're all like Python crowd says, we're all voluntary adults here. Like consensual adults. It doesn't even have private members. You just like underscore and a name. That means private. You can use
Ah,
it, yes, but
so a lot by convention
yeah.
and guidelines. I see. Mhm.
And the reasoning behind this, we're all adults here. You know what it means.
Mhm.
Don't use it. It
Mhm.
works in Python world. Right? So I think like if there's like holes like this where if you go out of your way to break your program and then you say, "Ha, it's broken." Yes, it is because you made an effort. You can always do
Mhm.
that. You can always just find an executable on disk, change a byte, and then rerun it again. No amount of like language rules will prevent you doing that.
Yeah.
So yes, you can break. It's just accidental mistakes that you weren't aware of. It's
Mhm.
supposed to prevent you from this.
That's really cool. Wow. So expression categories are just everywhere, and I'll be using identity and movability a lot
You used
in
it
my daily lingo.
twice today. I think this isn't where it stops.
Excellent. Cool.
Okay.
Do you have anything more to show, or does the audience have any more questions that we should tackle when it comes to value category? Excuse me, expression categories.
Just use value categories. Everybody knows them as value categories,
Okay.
but we can
I
have
would
an internal joke.
would it cause a little bit of a
Yeah.
subculture?
People
Okay.
Googling expression categories and finding nothing.
Nothing. Cool. Oh, it was really fun. I really, really enjoyed that episode,
Yeah, it was
and
amazing. And
it,
thank you. Yeah, I got another chance to explain value categories.
I'm fairly certain this time it will stick. And, well, in worst case, I go back to the video and watch the recording. And would you be up for more? No, I'm asking.
I don't know. This is taking a lot of my time, and also as I said, I'm a coin collector and runner, and currently I have a heap of old coins that I have to sort through. So I'd like to give some of my time to other hobbies. And like I said, I don't really code that much at work anymore. It's still one of
Mhm.
my interests, and so on. Let's see. Let's keep it at. I'm not saying no. Yeah.
Okay, perhaps. Well, I definitely found interest in this format, so we'll be doing in the future another episode. Not sure which concept we'll pick. Perhaps you go crazy and take a look at generics and templates. Maybe something that, well, I guess, is there really an easy topic? Maybe some sequences and innumerable and that kind of stuff, or
When
generators, I
you
think they
said
call in
which
JavaScript.
concept to pick, now in
Yeah,
C++ world, you have to stop using the word concept because it's now a keyword. It's a thing that means something
there is
specific.
a concept.
Yeah.
Ah,
So if you're
cool.
looking for a concept to pick, you could pick C++ concept.
Uh, a brief introduction.
Constraints and concepts. No, this is
That
just C++
no, that's not. No, that's
basic.
just a
Yeah, this one,
concept.
click on.
Concept.
Yeah, click. Okay.
So excuse me. No, which one?
That was a good one.
CPP reference is the one I should be. Yes. Okay.
Yeah, it's the Bible.
There is a concept.
Yeah.
Okay, that's also with generics. Okay. Hui.
Generics, but the next step.
Template.
Yeah. Maybe just a teaser, like how in generics you can use it with any type, and people realized it's sort of a duck typing, isn't it? Because you just write code and then you rely on it's duck typing, but not in a runtime sense, in a compiler sense. Why don't
Mhm.
we have sort of an interface, but for concepts, but for generics, right? Hence the concepts. So hashable in this case that you have on a screen will say whatever this type is. We don't know what the type is, but what it
Mm.
does have, we require from it to be to have to be able to apply the hash function on it and to get back a result of type size t.
That reminds me
So
a lot of TypeScript contracts. I'm not sure if I'm using the right lingo here, but this reminds me a lot of TypeScript.
I don't know TypeScript, so I can't help you there.
So it could be anything. It could be anything that has a function. It
No,
doesn't need to implement an interface or derive from a type.
no.
It just needs to have this shape.
In the case on your screen right now,
Yeah.
it's just that if I call std hash is a function,
Mhm.
if I call std hash and pass this the object of this type in, I expect to return to get something back that is convertible to size t. In effect, this means
Ah.
hashable, but nobody cares about how it's implemented, as long as std hash function can work with it. Right?
Cool.
Like an
That's
interface, but done differently.
So that's
Like
a
an
concept.
object-oriented, you could see how hashable could be an interface, right? And you inherit from it. But I think this is diverging into concepts. This was
So
okay. The end of the
what
trailer.
what's not a better word for programming concepts if a concept now is overloaded already?
I don't know. You just say concepts, but not that concept.
Not that concept. Yeah.
I have to go back to the drawing board and pick up a name. Now they've discussed 15 years for the X value. Yeah. So in 2035, we'll get a name for the concepts that are not concepts.
Excellent. Looking forward to it.
Okay.
Cool. Then I
Yeah,
guess
this was
I will
fun.
close as
Thank you very
well.
much.
This was interesting and educational, but yeah, quite a bit. You're very welcome. Thank you, all of you. Thank you much for joining. Thank you, Mate, for your time. I really appreciate your well preparation and doing this with me.
Thank you very much.
And
Thank you for
well,
having me.
there's a high chance I'll try to convince you for more, but let's see. Let's see.
Well, just mention concepts a couple of times.
So we're not sure when we do the episode, but it will be eventually happening. And until then, we'll be back.
We'll be back.
There it is.